Okay, hello and good morning. I think we're on. Yeah, I think we're on. I haven't done this for a while. Let's see. Are we there? Yeah, I think we're there. Okay, cool. Happy New Year. Yeah, so what's happened? So I was off the stream for a while because we had another kid. And it takes a long time to get into that stuff, into family routines. And it feels like I look like and I feel like I've been living in a cave for a month or something. Having holidays with two kids at home, one of them being brand new, is quite exhausting. But happy to be back into especially a new year and getting into some normal daily routines again. Very happy about that. Anyways, so I got my my oldest daughter, she spilled like hot chocolate over my MacBook Pro during Christmas, so I had to buy a new one. I actually bought the Mac. Let's see here. I bought this one. It's the MacBook Air, and I thought about buying the Pro. But looking at reviews and stuff, this is actually the one you should have because it doesn't have this additional fan that kicks in when you're doing like really heavy work. And it's amazing. Like, I love having a smaller computer. It's way faster and more powerful than my existing Pro, which isn't that old. Like a couple of years or something. Maybe even less. It's crazy, this M1 stuff. So that got me into some coding. So I've done a ton of stuff during the holidays, actually. I'm surprised how much time I got to do some coding. But anyways, so what we're going to do here is I've been working on... So we have some, like... There's a long history at Codesandbox in terms of the client and state management. I'm going to talk about that. And every time we do an iteration, new things happen and we identify new issues. And then we kind of just want to, it's not that we're in a struggle. It's just that we want to improve things. We have to move forward. And Codesandbox is a very special, special is the wrong term, but it's quite different than other web applications. Like I typically put it next to like Facebook. So for example, at Facebook, it's a complex application in terms of data coming from the server, but everything is driven by the data coming from the server. So it makes a lot of sense for Facebook to have something like Relay. By the way, I hope the audio is okay. I might have to configure a little bit, but I did some tests. It should be good. Anyways, so all the data is coming from the server, and that's kind of like how it works. You click something, more data from the server. You click something, more data from the server. So it makes sense for them to build something like Relay to make that better. But at Codesandbox, it doesn't work that way. We just have and at Facebook, the asynchronicity is basically fetching the data. Yeah, that's their async challenge. While at Codesandbox, we don't really fetch that much data from the server. We do a lot of side effects in the client itself. Like we have the code editor, the preview, we have like Git stuff, we have and all these different parts in themselves, like the bundler, and all these parts in themselves does a lot of different asynchronous stuff. So we kind of need something that fits for that kind of application, and I think Codesandbox is quite unique, and that puts us in a position where we should explore something that is designed for Codesandbox. And again, these are raw thoughts, raw implementations, and as I said, it's like built for with Codesandbox in mind. So a little bit of the history of Codesandbox. The client actually started out with Redux, and the immediate challenges there at that time, like this was written in JavaScript a long time ago, And Redux at the time, it's better now, but Redux at the time had a bunch of boilerplate, which is not ideal for new developers. And also the logic and the state was split across components and Redux itself. So one piece of logic, for example, loading a sandbox, was split between a bunch of different components and thunks and reducers. And it was just impossible going through the code to understand what actually happens when you load a sandbox. Also, the code discoverability was very low because it was plain JavaScript. And Codesandbox has a bunch of these little tiny functions all over the place, like for checking permissions and mocking out modules. We call them modules, like files and stuff. It's impossible to discover these things. And as I said, just understanding how the Codesandbox client worked at this point, it was just impossible. It was way too complex. And Redux doesn't have any concept of effects, so we imported everything everywhere, which made it super hard to do any kind of testing and stuff like that. So when I got into Codesandbox, we changed to Cerebral. That was kind of my how I got into it, because I was excited to see like a really big application. How would it look like if it was refactored from Redux to Cerebral? And Cerebral fixed a lot of things. It removed the boilerplate. We were able to, like, one example I use in the presentation, loading a sandbox was split between like 13 files or something with Redux, while in Cerebral it was only 3 files, and one of those files actually showed you everything that happens when you load the sandbox. And so it cleaned up a lot of stuff there. Cerebral also has a first class concept of effects. So we were able to isolate our effects. But anyways, it did a lot of good things. But we also discovered that there was some new challenges, which were that Cerebral had like a very exotic API that was very different from like how you typically approach writing application logic. Like we continue to have contributions to Codesandbox, the client. But yeah, arguably that API wasn't the best fit. And then it didn't really work with TypeScript. So when TypeScript popped up, we needed to kind of look into something new. Which I did with the team developing Cerebral. We looked at Overmind. And Overmind now is the thing that's running on Codesandbox, and it fixed the exotic API. It's a very straightforward imperative. Like, you just have a function, you have access to your state and your effects and your other actions, and you just write normal code, basically. And it also has the same first-class concept of like effects and all this good stuff. And of course, what I forgot to mention about Cerebral and also Overmind is that they have really good insight into the running application. Like, you see all the state, see all the actions running, what actions calls other actions, the data pass between them, all the effects being called, what they return, like tons of information. But what we have discovered using Overmind and well, it's not Overmind in itself. You would have this issue with other state management libraries as well. It's that we want to use strict NullChecking, which basically means that in our namespace called editor, we have a sandbox, but it might not be there. The sandbox might not have been loaded yet. So it's typed as a sandbox or null. And the problem with that is that every single place in our code, in any action, in any component that wants to look at a sandbox, we have to check, is it really there? Even though we know that the component isn't mounted, unless there is a sandbox there, or the action isn't called unless there isn't a sandbox there. And this says something about how everything is structured. So that's not ideal. And then we also have this decoupling of state and logic, like state and actions. And that's actually really bad for discoverability. So when you look at the code, even though the state and the actions themselves are part of a namespace, you don't know what state each action operates on. Like there's no concept between state and logic because they are decoupled. They're two completely different things. So you can think of it as like a thunk and a reducer. They're decoupled. Unlike you have, like with MobX, for example, you would have a class. And in that class, you have your state and you have your actions. They're coupled. And that improves discoverability. Because then you have this domain-specific thing. It's like a class. You can point to it. And then it shows you all the state that's related to that feature or domain or whatever you want to call it, and you see what actions you can call related to that thing. And also like in terms of private and public logic, in Overmind you don't really have that. All the actions are public, while you certainly do want things to be private. Yeah, exactly. And then more concerning things is like and this is not Overmind specific, really, none of these things. It's just something that we have now gotten to that we want to solve. And it's like async race conditions. When, as developers, we code for the happy path, typically. It's kind of like really diving into this. It kind of blew my mind how badly we. I shouldn't say we. I'm meaning me. And what I've noticed through my experience developing applications with other developers as well, we are not really good at dealing with errors and bad states. So an example of that, and you see it in all these popular solutions as well. Like a typical example is you're going to log in somewhere, and when you click the login button, like nothing happens, and you continue clicking the login button. And what happens is that it logs in again every time you click, and you never enter the site because of that. And that's like just one example. But then you also have these transitions within an application. So for example, so let's take Codesandbox. You go to the dashboard at Codesandbox, and then as you're loading data, you switch to a different workspace. And then when you switch to that other workspace, suddenly you get the response from the first workspace. So suddenly sandboxes from the other workspace pops up in the other workspace. Because we have this race condition. So we don't have any concept that I have seen in state management solutions that disposes of what's currently running it. And even in the language itself, like we haven't had cancelable promises or anything. So this concept of disposing things as the user moves around is something I think is really, really important, but it has to be like ingrained into the solution, so you don't have to manually do it all over, because that's too fragile. We're going to look at that, and then it's also resetting state. Like in Codesandbox, as an example again, you might open a sandbox, you have something related to deployment or Git or some other part of the editor experience that is tied to the sandbox, and then you change the sandbox, and suddenly you have some state that was related to the previous sandbox because it wasn't co-located. It wasn't part of the same thing. It's decoupled. yeah. So maybe I'm over explaining all of this, but this is what I meant about null checking. So what we have is like current sandbox, it might be there or it might not be there. And as I said, we have to check this all over. And it creates like really, it doesn't feel right. And you have all these checks that's only there to please the typing. Yeah, so we have all the state and the logic decoupled. So as I also mentioned, we have things like you just do some random import from some common utility thing, and you don't know that it's there. You're not able to discover it by pointing into the application. I mean, like pointing as dotting into things and discovering it. And again, like you see the null checking here popping in, like we want to check the permission of the sandbox. We don't know that there is a has permission function, and we don't know if the sandbox is there. And again, no private and public logic in Overmind. Everything is public. You could say that, why don't you just create a function, like a utility function? That could be private, and that's true. We could do that. But then we would have to manually pass the context to these functions. It's the same in Redux. Like if you want a private piece of thunk, you would have to pass the get state and the dispatch to that function for it to be able to do things, which is not ideal. And then we have, race conditions. Here's an example. We have a sandbox. We don't really know if it's there. Again, null checking. And then we await for something from VS Code, for example. And then maybe we forget to dispose like a listener. Maybe we change a different sandbox. Maybe the user is logged out for some reason. Like all kinds of shit can happen while it's awaiting this update. Yeah, and we don't really deal with that. And then again, resetting state. What if you change a sandbox and there's nothing happening? Like we're not resetting related state when you change the sandbox, for example. So again, this is not, I see these as general state management challenges and issues that aren't really dealt with in the state management solutions themselves. This is something you have to like architect or plan around, or whatever you want to call it. So these were the things that were on my mind exploring this new concept. And I also thought about making some improvements because a big discussion has been, like, this is becoming a presentation. I didn't really prepare this stuff, so I'm just rambling along. I hope you find it interesting. Anyways, so a big concept generally in programming is that you want to isolate things into features, really. That's ideally you want to think about an implementation as a very concrete thing. In isolation. The problem with isolation is that it can't really depend on anything else. You have to pass everything into it. And that, if that feature is of some size, that is problematic. You can compare it to props passing, for example. You just pass a bunch of props into the root component to give it its dependencies. And then it has to pass all these dependencies down into the different children. It would be the same thing. It's not ideal. That is why, for example, React has the concept of context and being able to inject dependencies into components, for example. Yes, and this is the same thing in Overmind as well, and other state management solutions. You kind of have this. Like the thunk in Redux, it has access to all the state of the application, and so on. It's the same in Overmind. You have access to all the state and all the other actions wherever you are, because we don't want that isolation. because of the consequence of having that hard isolation. But what we're going to look at is a way to have that isolation, like that isolated feature without the dependency isolation. It will make more sense. And then I'm really like, this is the whole thing with Codesandbox as well. We are really looking into how can we provide more UI to be more efficient at developing. And we don't mean like building a visual code editor. We are looking at it from the point of the code itself. Like what parts of the code can we put into UI to more effectively work with the code? Which means that the code needs to be in sync, meaning that you never leave your code. You just have some visual tools that help you write your code more efficiently or understand your code more efficiently. So it needs to be in sync. But I also want to have been thinking a lot about is how restrictive files and folders are. Like this is how we, when you go into code base, all you have to go by without running the application is files and folders. And if it's a really well-structured project, it does give you some really good indications. Like you might have like a features folder where each feature has its own folder and each feature has its own state and actions and utils or something like that. That gives you a good indication. But you don't see the full picture, especially when these different features starts depending on the other features, which is by definition, like this is how Codesandbox is. You have all these isolated features, but all of them kind of depend on each other. So yeah, you don't really get that in files and folders. So I wanted to do something about that. And then also just getting insight into the application without even running it. So that's the power of files and folders. You don't have to run the application to understand how it works. You can actually just look at the files and the folders. But what if you had something else? So an example of that would be if you've seen the Webpack bundle analyzer. You can build your project with Webpack and you will get like how big is each bundle. But the Webpack bundle analyzer gives you this amazing visual overview that shows you instantly which bundle and like relatively how big is it. Like they have these squares. And then you can see within each square, you have the dependencies and you see how big they are. So you instantly see if you have some dependency that seems a bit off or whatever. And that's what I'm talking about here. Having that kind of some insight into the application without actually having to run it. So with Cerebral and Overmind, the dev tools are really amazing, but you have to run the application. And even then, you basically only get insight into whatever is running, like whatever you interact with. It would be nice to get like a general insight into the application. Anyways, so I think it's time to... Yeah, thanks. Yeah, I'm happy to be back as well. I miss doing the streams. Let's see. Okay, so I have something. I built this service some time ago, Boil Project IO, I think. Yeah. So I built this and I thought I would use this. So we're going to set up a simple project. Let's see. I actually think I'm getting... Oh, I have to authenticate. Let's see, and that's 725864. I have some old authentication here, which is deprecated. I have to fix that. But anyways, this Boil project thing was a reaction to having such a hard time setting up basic projects, like very simple things. And now I go to Codesandbox to do this, but sometimes I have to develop locally, and then this is really nice to have. So yeah, let's just use this one. So basically you log in and you can set up different boilerplates, but you set them up like this. You kind of create files and just type in whatever. And then if you want to set it up, you can just go here and you can say boil project Christian Alfoni. Was it React? No, basic. We do want React. Emotion, Babel preset. Yeah, no, let's do the basic one. Yeah, let's try that. Basic. And then that should kind of just run the thing. I haven't done this in ages. Let's see. Let's see what happens. Yeah, anyways, while that's working, we have our little project here. Editor watch, npm run editor dev, and then let's build it. Okay, so this, like, I call it reactive app for now. Again, this is not meant to be like, maybe it, I don't know, I haven't even talked to the team about this. I've given them some hints, but there's a window opening at Codesandbox to look into how we can do state management differently. Like this is the most challenging thing. Like when I refactored Redux to Cerebral, that was a crazy refactor. And maybe even crazier was refactoring from Cerebral to Overmind. Like you need a solid strategy to make that work, because you have to do it in steps, but you also have to ensure that those steps doesn't lead you into never finishing it. You have to finish it. So I found an opening for doing a change now, so we have to make a decision on this rather soon. But I thought it would be valuable to just talk about the different challenges in general and do some refactoring, so I have something to kind of show to the team and say that, okay, this actually fixes some issues. Cool, I think this was working. And then if I just open this folder, development, temp, Codesandbox refactors. Yeah, this is looking good. Terminal. Is it running? npm start. Let's see. Let's see. Localhost. What do you know? It actually worked. That's nice. Yeah, boil project IO. Check it out. Anyways, let's see here. We need to actually install Mobex and Mobex. Is it Mobex React Lite? Well, I guess we're not going to create any UI for now, so let's just install Mobex. And then we need to link in reactive app. There we go. And now I think we can run the editor. Let's see what happens. Oh, I have to actually add it. Oops. Let's see, editor. And this needs to be node node modules reactive app. Oh, I have to do something special here. I never remember this. This is just because it's not published to npm or anything. Is it dist? No. Is it out? It's out, I think. Was it? No, bin dev. Yeah, I added this bin dev. Okay, let's try now. And here we are. Great. Okay, so the thing is, what happened now when I fire this thing up is that we actually got a folder called app, and it fired up, and it actually wrote this file, index file, for me, and imported something called a container. So what's interesting about this approach is that it's not, because of the way like Redux and Cerebral and Overmind and related solutions do it, with that decoupling of logic and state, I had to find some concept that allowed us to put it more together, but still have the possibility to access dependencies in that concept of isolation. And it's kind of funny because I worked as a consultant for about a year at the company before joining Codesandbox, and they put me on a C# project. And I had never written C# before, and I was happy to see that all my TypeScript experience helped me a lot diving into that language. And they have a very strong concept of dependency injection. And it's really interesting to see like where TypeScript comes from. It comes from, well, I don't have any facts here, but it comes from the company that built C#. Isn't it Microsoft that did that? Anyways, it comes from Microsoft, and if you look at the code base of VS Code and you see the collaboration with Google on TypeScript, it's a lot about dependency injection, but it's such a low-level concept. So I was thinking, like, what if the state management tool itself has like a first-class concept of dependency injection, so you don't really think about it. It's just part of it. So that's one part of this thing. So we're going to look into this. Maybe I should just do something, and then it makes more sense. Let's see here. What should we do? Okay, so the point is, we are going to build like a new feature for our application. Let's just think that to do MVC thing, and then in our next stream we'll actually find some Codesandbox code, and we'll start like building up some Codesandbox stuff instead. So what I'll do is I'll drag this new feature, and the cool thing is that if I already had an application here, I would like see everything. All the features would be here. I would see how they were all connected. And if I were going to add a new feature, I would kind of have to fit the feature into the space of the application first, like the mental space of the application. The feature has to fit, which means that I might have to move other features around a little bit to make the new feature fit, which is a concept I really, really, really like. It's not just about implementing it. It needs a mental, it needs a position in space, kind of. But anyways, I'm going all abstract here. So let's say we want to create like a to-do app. Oh, I think it broke. It broke. Unexpected token. Oh, what did I do wrong? Oh, I've been writing this stuff on my other unexpected token. And why is it this? Has no exported member. Ooh, am I missing something? God damn it. Sorry, I didn't test this before I started. It seems that I'm missing something here. Let me see. Didn't I build it? Yeah, I did. So why doesn't it have the... It's there. Oh, wait. Maybe it's the cache. Delete. Then we'll run this again. And then let me just start running well, this shouldn't matter really. Oh, is it? Oh, god damn it. Sorry about this. Classic. That's so weird. Well, it might be, let's see. Oh, of course. Sorry. It's because I don't delete these folders when I build it, which I should. Because it has, like, I changed the file names and stuff. So then suddenly I have some old files in there, and then it breaks the... Let's restart now. But I do wonder what this error is. Why did it say that? JSON parse element get text. Oh, is it? Oh, I think I know why. Oh, that's interesting. Ooh, okay, this is very interesting. Single quote false. This is the thing. It requires. Oh, that's super interesting. Okay, anyways, let's fire it up again. Now it should be good. If it's running. It's running. Why aren't you working? OMG. Oops. Run editor. Watch. Why the hell aren't you running? It's as if localhost. Am I running something? OMG. Site can't be reached. Oh, run editor dev. Let's see now. Oh, there we are. Okay, so we've added a feature. So we have this to do thing, and now we want to build this thing out in isolation. So what does a to do need? And this is the thing, like what should be visual coding and what should be actual coding. So for example, adding like properties to this to do, that doesn't make any sense to do that visually. You do that much better in code. So let's do that first. Let's see. So I can click this, it opens the file, and I can start adding like, okay, it needs an ID, needs a title, it needs a completed state, for example. So as I save that, this thing just updates and it shows me the properties. And then maybe I want to be able to like toggle completed. And what this does, it says this completed equals this, like that. And I also get like a method here. Now the cool thing is, what I want to do with this to do is that I want to be able to observe changes to the title and the completed state, right? So this is something that that you can do better visually than you can do in code, because here we can just click them. So as I click this now, I'm making them observable. And if I go back to the code, we can see what it actually does to the code. And what it does is that it writes this make observable thing. And this is, the thing is, we need some reactive behavior in state management. And the question is like, how do we do that? And I personally prefer the way Overmind and Mobex does it. Like you have this mutation imperative approach over the immutable functional approach. That's just a preference of mine. So this state management library actually uses Mobex under the hood, where you actually have this make observable thing, but it's integrated into the tool, which means that we don't import it from Mobex or anything. The state management solution understands that this to do is a feature, and it allows you to call this method to make things observable, for example. Now, the cool thing is that if I remove completed here now and go back, you see that it's not there anymore. So this is analyzed in the code and it's kept in sync. What I also want to do is that this toggle completed is just a normal method. But I want it to be an action so that I can actually change the state, because Mobex doesn't allow state changes unless you explicitly say that the method is an action. And I can do the same. I can click it. And what happens now is that I can also run this action. It actually tracks the execution of this action. And again, it just does this thing. If I were to change the name of this thing, I should have gotten... Oh, I think I'm missing some tsconfig stuff. Yeah. That's kind of weird. It should have given me a TypeScript error here. I'm not sure why it doesn't do that. Oh, props any. Oh, that's interesting. Why does it say props any here? Which version of TypeScript am I running? Yeah, this is some old stuff. I'm not quite sure what's happening here. Package TypeScript. It's latest version. Anyways, let me explain how this actually works. How does it understand that it's actually a feature? There is this, so dependency injection isn't something that is very much used in like in general. I've never met it anywhere in my career in JavaScript. I've seen it like in VS Code, for example, but I've never seen, like in all these discussions about managing state and stuff, never seen it. What I have never seen as well is something called a mixins pattern for classes in TypeScript. So if you have a class in TypeScript and you export an interface with the same name as the class, and then you start extending something, then it will actually understand that this class will actually inherit the typing from whatever you extend here. So in this case, we're importing this, we're extending this feature, and then now we have the typing for that feature. So as you can see, we have inject features, we have make observable, reaction, when. This is stuff coming from the feature. While this static mixins here just ensures that the runtime actually inherits feature. Maybe I'm going too deep into technical stuff without actually showing you how this, the benefit of this stuff. But as I said, I haven't really prepared this, so we will just dive into it, and then I hope things will become more clear as we move on. What I'm very curious about is that why the hell doesn't the typing work here? Make observable. This was working on my other computer. I wonder if it's my... I don't really need all of this stuff. Oh, maybe it's this thing. Let's try to do this. See if it's more happy now. Let's restart the server. Yeah, this is really weird. It's as if it doesn't really take into account Yeah, I have no idea why this doesn't work. I'll have to explore that. Anyways, the point is we have now the capability of writing this logic in isolation, and we can use the UI to do other things more efficiently. But where things starts to get a bit more interesting is that we can say that, okay, we have this to do, but we don't want to have one single to do in our application. We want to actually create to dos. So we can say that this is a factory. And that means that whatever other feature that uses this to do as a dependency won't just get a to do. They will actually get a factory to create to dos. So let's add a new feature here. Let's just call it storage or something. To dos. What should we call it? To do storage. Okay, so we have a new feature, and we want this feature to be able to create to-dos. So basically, this to-do storage would talk to local storage to store the to-dos there, for example, and would actually be where our application actually gets the to-dos to display them in the UI. And what we're able to do here is we can actually drag a line here, and now like the management system or the library or whatever you want to call it understands that, okay, to do is a factory. So we are going to inject or make that a dependency, and we're going to name it create to do. So if we look at this to do storage thing, we can now see that we actually have a new property here called create to do. And it's a type of to do, and we're actually injecting the feature, as you can see here, which means that if, for example, we say create or add, maybe add, let's give it a title, we can say, okay, this create to do, and then we pass it the title. Although we don't have, let's see, we are not grabbing the title here. So let's say this.title equals title, like that. Or you can give it the ID as well. Let's just do string date now. And then this.completed is false. And the good thing is that all of this stuff is typed. So this factory is automatically typed for you. You don't have to think about that stuff. It just works. And then we want, in this storage, we actually want a list of to-dos. So this should be like a to-do list. And then we can say this to-dos and shift to-do, for example. So this is how we're adding a to-do. And we want our to-dos to be observable, and we need to be able to change the state. So we're making add an action. So, and this is not a factory now. So what we should be able to do is go into our code. We should be able to import our container from the app, and we should be able to say storage container get to do storage, and this is considered a singleton. This is like a dependency injection term. Well, it's not a dependency injection term, but it's the, one of the kinds of instances you can get. You can get a singleton, which means that it doesn't matter who requests to do storage, it will always be the same instance, and the first thing that wants access to it actually creates it. And then you have the factories, where you rather get a function back to create multiple instances. Anyways, so what we can do is we can just add my awesome to do, like that. And then if we were to, where are we? Refresh the application, we actually see this view start come to life. So we have our to-do storage, and we can actually now see that we have a to-do here. And we can take a look at it. It's completed, false, my awesome to-do. We can see that it is an actual to-do. And we can actually click this. And now it moves us to this factory that created it. And we can see the title, we can see completed, false. And we can try to toggle it. So since this is a method that doesn't have any arguments, I can just run it. And we can see that it runs. It doesn't have any arguments, and it changed to completed true, for example, in this case. We can also go into our to-do storage, and we can look at the dependency itself. So we can see that it actually created an instance. This should actually be called to-do, but what I mean is like these two are actually the same. So you can go and look at, okay, so what instances were created by this specific dependency injection? That's the thing. Okay, cool. So this is really kind of what I want to, where I hope to kind of catch your interest, is what I did now. I built two features. I made them depend on each other. I made the application run, and you can actually see it starts populating with data. And the point is that this gives you so much insight. So imagine being a new developer, and this is something that Codesandbox is going into now, is we're going to hire quite a few developers, and being able to open this editor and just see everything. You see everything that is of importance, the reactive parts of the application. And you can explore all the methods. You can imagine having tools here that would show you, like everything here is populated into this node graph thingy. But you can imagine having tools for looking at mutations chronologically, pointing to the different instances. You can click the instance to look at the mutation. You can do like time travel. As you navigate through different instances, you can move back and forward, and you can do, there's so much stuff we can do here to improve the understanding of the application. And as I said, if you want to build a new feature, you just drop it in here and you start connecting pieces. Anyways, there were a few bumps there to be expected. Again, I'm just doing this stuff. I'm just jumping into it. I don't have time to prepare anything. But what we're going to do next time is that we're going to dive more deeply into the concepts here and look at the actual client code of Codesandbox. And we're going to start refactoring stuff and see how it feels like. How would it actually look like if Codesandbox was written in something like this? Yes, that's the point. And you might you probably have a bunch of questions as well. So please just write questions in the comments and I can answer them tomorrow. And yeah, I guess we should just stop there. But yeah, it's good to be back. I hope the audio was okay, or I'll make changes to it for tomorrow. And I hope I piqued your interest with this, and I hope to see you again. And yeah, maybe this will become a thing, maybe it won't, but it's, for me, just the concept itself is a really fresh take on state management, I think, which actually deals with some stuff that as developers we don't deal with very much, which I pointed out in the introduction, which is this async nature of our applications. And we're not like, we have all these race conditions that it's very, very hard to pick up because we have a tendency to code for the happy path and test for the happy path. And we don't do these crazy things where maybe the network is a little bit slow and then the user changes something, which means that this asynchronous thing now is resolving in the wrong context. It shouldn't even resolve. Stuff like that, which this thing deals with. I haven't shown you any of that yet, but I'm going to. Okay, cool. Bye for now. Thanks for following along. Happy New Year and have a great day.